Hello, this is Jeffrey Fox, the instructor of Big Data Applications and Analytics. And in this lesson, lesson 6 of Unit 2, we're going to discuss the computing model, which is the cloud computing model, which is essentially arose to process big data, because the problem, the e-commerce and search and social media produced for the early Web 2.0 companies was the enormous amount of data, because they tapped the world, and there's a relatively small amount of data multiplied by the number of people in the world is a big number. Remember, the total amount of data in the world today is actually around 1 terabyte per person, summed over all people in the world. Here's an interesting chart from Gartner, discussing big data and cloud computing, as well as their hype curves. They have these priority matrices which plot transformational through moderate in terms of benefit against the time to realization. In 2012, I use this because it's the only one I have which has 5 different years on the same plot. 2012 media tablets, for example, were transformational in the near term. Big data and cloud computing was transformational in a 2 to 5 year period, and we have in later various variants of 3D printing. If you look at this chart, you see 3D printing is a dominant trend, and cloud computing and big data are also important trends. Except big data only popped in there in 2011 at the same place as cloud computing. Still there in 2012. Cloud computing is present in all 3 years, which is actually it's present forever, and which is slightly inconsistent with the 2 to 5 year timescale. Obviously, it took longer, or else it was so important it was incredibly transformational for many more years. I noticed Gartner has moved big data in 2013 to the 5 to 10 year slot. I have not seen this priority matrix for 2014. I mentioned you have to troll around the various blogs to pick up this nifty information from Gartner, because it's not directly published. Here's interesting statistics about Amazon Web Services, and they took 8 years to hit $650 million in revenue, and now they're actually up to 3.8 billion. So that's just from 2010 to 2013, increasing drastically. If you use the standard model to relate the value of a business to its revenue, you find that Amazon Web Services, the cloud part of Amazon, is worth 19 billion. And Amazon is the first public cloud and the largest public cloud computing vendor. So it's just providing clouds is an important business. What are clouds? Well, actually, physically or operationally, they're pretty clear. They're a bunch of computers, which is a well-known thing to have in a computer center. Those data centers are incredibly efficient. They have excellent connection to the internet, so everybody can use them. And I say they were produced to serve the public-facing Web 2.0 e-commerce social networking sites, from Google search through Amazon e-commerce, through Netflix, through Facebook, through Twitter. And in some sense, a cloud is an optimal giant data center with a good internet connection. And you can also look at private clouds, which are the same type of data center, the same efficient data center, but not so optimized for internet access, and probably not quite so big, because that's just serving an enterprise, whereas public cloud serves the world. And there are more people in the world than there are for any one enterprise. If you look at this picture of Microsoft clouds, they're built around data centers which have, well, probably the smallest one is less than 100K, but the biggest ones are from 100K to 1 million servers. They sometimes are built in terms of shipping containers, with 200 to 1,000 servers per shipping container. And here are some pictures of Microsoft centers in various places around the world. And over here is a picture of the so-called fourth generation one, which we'll see in a somewhat larger size in the next animation. And this picture shows you a measure of the size. And this comes from an October 2012 talk by Dennis Gannon. And this shows this fourth generation data center in more detail. It's sort of outside because one important feature of clouds is actually previous data centers were optimized for robustness. Clouds are so big that they have to face fault tolerance square on, and that means they actually don't have to be as fault tolerant because they have so many good fault tolerance recovery issues built in. And therefore, actually, you can save money on both the computers themselves and the data center. You don't need as much plumbing for keep them cool, because if they run a bit hot, they just fail a bit more often, and so be it. And say here's some various units, like the shipping container as the unit. You just produce a bunch of places to plug your shipping container in. And here we have the next slide, which is also comes from a somewhat older talk by Microsoft, 2009, November 2009, and it just points out that one of the major motivations of clouds is simply economies of scale. And this compares the cost of a small size data center of 1,000 servers to a large data center with 50,000 servers. And this just looks at various costs, showing that there is typically a ratio in terms of around 6 to 1, 7 to 1 in terms of cost, just coming from the fact that you can run a given system admin can run many more servers than than they would see in a small center. So these are the life cycle costs, which are of course very important. They're comparable or probably larger than the actual raw initial hardware cost. And so if you can cut the life cycle cost by a factor of 6, that's enormous. Here is a sort of depiction of the size of a typical data center in 2009, and it's meant to be over 10 times that of size of a football field. Is your favorite football field? American football, that is. This overlay shows some more pictures here. Here we have the Google warehouses of computers on the Columbia River in Oregon. And this tells you, actually, these are the typical power uses of a big data center, from 20 megawatts to 200 megawatts with around 150 watts per CPU. And obviously, this points out that it's interesting to position them where you can get cheap power and where you can easily access the internet. Here, in Oregon, you're emphasizing the cheapness of the power. So what about virtualization? So virtualization are typically built in clouds, and this has several important features. Virtualization gives you an abstraction of just running a job and you don't know where it runs, so that's important. That means you can actually do this from your client in Timbuktu and run your job on a virtualized system, and it doesn't matter that that virtualized system is sitting in Oregon or Chicago or what have you. Virtualization also allows you to use hypervisors, which support images, and where an image contains the OS and the application. That allows you to remove the problem in many data centers that they have a fixed OS on the computer, and you want to run an application which is inconsistent with that OS. All these applications are very sensitive to OSs, even when the OSs are identical. They're all inverted commas Linux. So another important aspect is you can pack multiple virtual machines on a single machine, so you can do the stacking, and that's typically a big factor of improvement of enterprise systems. You no longer need to have a separate computer for every application. You just run multiple applications, each to one virtual machine, so they're isolated and clean, but you put multiple virtual machines on a single node. So that avoids, again, virtualization you can actually have systems running different OSs on the same node. And further, using virtualization improves security, and we know security is a critical issue because virtualization hides the really sensitive issues from the user. Here's the server consolidation issue illustrated with some numbers from Microsoft. This is the point that you can take an existing collection of applications, each running on a separate machine, put each of those applications on its own virtual machine, and pack those virtual machines on a single machine. And there's some number here that at least around late 2008 or so on, you had about 10% utilization in an enterprise system, and Microsoft was able to take 5,000 SQL servers, rehost on virtual machines, and get a 6-to-1 consolidation. Needed factor of 6 fewer computers, and that was a 60% saving in operations for that particular customer. Of course, you can say that's very bad for the people who make computers, but not really, because we've exploded the use of computers, and there are lots and lots of computers in this world, and the number of computers being purchased keeps growing. Here's an example from Google of a similar issue. We have look at email servers and compare here Gmail running on a cloud with essentially an infinite number of servers versus various small businesses, medium businesses, large businesses with users going from 50 to 10,000. Here's the number of servers you need. You do need a lot of servers in Google, but that's what Google has. And then the cost per user goes from 8 watts to a factor of 50 improvement, and the power usage efficiency of the actual data center is a factor of 2 better for a big data center with optimized cooling and power delivery. It's a factor of 2 better than the small data centers, and so the total power per user is a factor of 100 better. So that's another illustration of the advantage of the cloud being just more efficient and cheaper in terms of use by the users. Here is what NIST says clouds offer: on-demand service. The clouds are sitting there waiting to be woken up. That's elasticity. You don't have to buy as many computers as you might need. You just rent the one. Whenever you need more computers, you just rent it from this infinite pool, and which is not really infinite, but it appears infinite, from Amazon or Azure. You have these network access. You have these pools of resources, a very flexible allocation process, and you just an important business model. You just pay for what you use. You do not pay for the whole system. And then we have these economies of scale we've already discussed, performance and power, and software models, which platform as a service, which has all these nifty things like MapReduce, Memcached, to in-memory databases, and HBase and stuff like that. And at least in principle, this is always cheaper than buying your own. Now, of course, people always prove that's not true, but I'm not certain those analyses are correct. And although originally Amazon was infrastructure as a service and Azure platform as a service, they're now both. Here's a picture from Gartner about various services. We're talking about a particular application set, business process management, and some measure of that particular application, which is this thing here. So it's increased per year as not quite, is almost as large. I mean, actually, here's the overall statistics: infrastructure as a service, 41%, software as a service, 17%. That's shown over here. And this particular application, business process management, actually slightly below the average software as a service. So it's not especially a dramatic example. Here we have the final slide in this set. Again, comes from another Gartner report on the web, which I put the URL up here. The so-called Magic Quadrant, which plots ability to execute, capability versus the completeness of the vision. And we see Amazon as having leadership in everything according to Gartner, followed by Azure, which is Microsoft. No, Google is down here, and IBM. These are just not, they started a little later in terms of the broad infrastructure as a service offerings than the other vendors. Obviously, IBM and Google could be very competitive with these vendors, although often number one is number one for a long time. And here we have a lot of specialized smaller services: GoGrid, Rackspace. VMware is mainly a software company, but obviously has its own clouds as well. So this is a very vital and rapidly growing area. The provision of clouds for people to use is those clouds are then used in these various applications. These ex-informatics use clouds to deliver on the informatics and run the analytics and so on. So that's the last slide in this particular set, and that's the end of this particular lesson, which is lesson 6. Thank you very much.